Are we playing? Right, so consider if you're in a lift, right, and you're standing on the weighing scales. If you are accelerating up, the reading on the weighing scales will go up. If you're accelerating down, the reading on the weighing scales will go down. Constant velocity, you will just see your normal weight. So what exactly does the weighing scale measure? It measures the normal contact force exerted on you by it. So what is that normal contact force? I'm going to consider down to be the positive direction. So the normal contact force of the weighing scale on you is going to be minus mg, that's due to your weight, plus ma. So that's the acceleration that you undergo. So a couple of things to look at here. If you're going at a constant velocity, the acceleration is going to be constant. The acceleration is going to be 0. So the normal contact force is just equal to your weight. If you are, I said down was the positive direction, if you are accelerating down, well then you will see that this quantity and this quantity are in opposite directions, I suppose. And so accelerating down reduces the weight. If it's accelerating down more than the weight, more than gravity, more than 9.81 meters per second squared, then you lose contact with it and there is no contact force at all. Next thing I wanted to quickly talk about is, let's imagine now what we will see on weighing scales as we're standing on a lift and we press number 3 to go up a couple of floors. What's going to happen is our velocity time graph is going to look like this. We have to speed up to a constant velocity and then we're going to slow down to 0. So that's what the velocity time graph looks like. So we know if we get the gradient of the velocity time graph at every point, we're going to get the acceleration time graph. So let's see what the acceleration time graph looks like. We've got to do a negative one as well. So there's 5 points to this graph. 1, 2, 3, 4, 5. First section of the graph. Velocity is increasing and rate of acceleration is increasing. So that would mean something that looks like this. So for the acceleration time graph. Now, 2 is the velocity is increasing, but the rate of the acceleration, the rate of change of velocity is decreasing. So you get this. Now, what you get is you get no change in velocity, so the acceleration is 0. And now what you get is you get the velocity is decreasing and the rate of change of that is decreasing. So you get this. And then this last section, it will look like that. So that is the acceleration time graph for your acceleration on the lift. So we just stop that one there.